Okay, today we are going to talk about 10.4, or evidence of evolution. So at this point we've started talking about Charles Darwin, and we've started talking about his theory of natural selection and kind of some of the different similarities and variations he's seen amongst species, which led him to the vocabulary word adaptation and variation. So that goes back to the finches, and that goes back to the turtles, the different things that he noticed. So now what we're going to say is not only can you see differences and variations in the tortoises and in the finches, but you can see common ancestry amongst many different species. All you have to do is look for it. So the first thing that Darwin looked at was he just looked at a simple fossil. And he said fossils definitely provide evidence for evolution because as you dig deeper into the earth and you find older and older fossils, you can compare them to creatures that exist today. So let's take armadillo. If I go and I dig a hole in the middle of the desert, I might find an ancient armadillo-looking creature, and maybe that ancient armadillo had a shell that looked like this. Okay, so it had different spikes and everything on it. And now I compare that ancient armadillo with armadillo of today. Well, the armadillo of today doesn't have spikes on it, but do both of them have sections in their shells? Absolutely. All right, so there's a similarity, but here's a difference. So could they be ancestral related? Yes. So fossils definitely provide that. If you look at the fossils of chimpanzees and compare them to humans, and you look at them over the course of time, what you notice is we have an awful lot of similarities amongst us. So, and I don't know how good you're going to be able to see this, probably not that far away, but if we look at this picture right here, we have a human, and then you go all the way back to the first ape-like creatures. Look at all the similarities amongst us. There are pelvic bones, similar. We have the same leg structures, our cranium or our skull. We have the same types of rib cages and fingers and hands and arms. So there are a lot of similarities when you look back at different fossils. So fossils are a great piece of evidence. Okay, something that we talked about a little bit in freshman science is how does geography play a role in evolution? And we said that if you have land masses that kind of match up, and then all of a sudden they separate, think of Pangea, so Pangea is close together at one time, big blob, and then all of a sudden Pangea breaks apart, and you have piece here, piece here, piece here. Well, if they're all separated by ocean, why do we have a non-swimming creature here and a non-swimming identical creature there? Well, what that tells us is at one point in time, those land masses must have been closer together. Same thing goes on this side. It says island species, they resemble the mainland. So let's pretend it didn't break apart. Let's say this is the mainland, and we have a small island here, a small island here, a small here, and a small here. All of these birds that are found here look very similar to the same bird we found here. Well, same species could adapt to their different environments or different food sources, but that's still going to show you that environment and geography play a key piece of evidence for evolution. Embryology. Embryology is just when you go back and you look at the beginning stages of life. So you look at an embryo. And what you'll notice when you start looking at embryos is you'll notice how similar all of these species are. A picture that shows a really good job in the book is there is a picture of a rabbit, a chicken, a human, and a mouse. And if you look at embryonic development for all four of those species, they all look the same. They kind of look a little bit, and excuse my drawing here, a little bit like that. Okay? When we look closer at these, what we're going to notice is all of them have a head. So no matter what species you are, you have a head. And then all of a sudden we notice these gill slits. So they have gill slits. And then we notice down here, you have a tailbone. There's an eye socket. Now, as you continue down the path of development, do we look identical to a chicken or a rabbit? No, absolutely not. But in embryonic stages, they look the same. Look at the same slide here. You have two different species. You have an adult barnacle and you have a crab. But look at their larvae. They look identical. But as they continue to develop, it totally changes. So embryology just adds another piece of evidence for evolution, because it's saying, look at how similar things are in the beginning, and then look at how they change with time. Well, is change with time not the very definition of evolution? So it's a great piece. Okay, the last piece of evidence to talk about is anatomy. When we look at anatomy, or we look at the structure of how something is built, we're going to notice a lot of evidence for evolution. Homologous. Think back chapter 6, chapter 7, chapter 8. Homologous means the same. Same thing here. So we have a human hand, a mole foot, and a bat wing. Are these identical functions to each other? Absolutely not. But are they all similar in their structure? Yes. The human hand, the mole foot, the bat wing are all built the same way. They have the same bone structure. So homologous structures mean similar structure, different function. One of the key things to kind of point out with homologous is homologous shows common ancestry. So if you're closely related to another species, that's going to show, hey, maybe on that tree of life, maybe we were closer to the bottom together. Maybe we weren't so far apart, because homologous structures show that. And I know in my class I've talked a lot about the book The Inner Fish, and I talked about how these scientists were trying to find the link between water and land, and they started looking at fish, and they were comparing the jaws of fish to the jaws of different types of amphibians and reptiles, and eventually they led to mammals, and how all of these pieces connected the picture of evolution. And it was all by studying fossils and the similarities of their anatomy. And a lot of times, too, the geography played a good role in this. And the reason that the geography played a good role in this is because where scientists found the fossils gave them pieces and kind of clues to where that creature may have existed. Now, obviously, embryology wouldn't help because we don't know the early embryos. Cartilage tissue does not last, so unless you find fossils or calcified bone, we can't compare it. So homologous means same structure. That's your key thing to take away from this slide. The opposite of homologous in this case is now analogous. Analogous just means similar function, different structure. Okay? So if we look at a fly wing and a bat wing, they both do the same thing. They help each species fly. But are they built the same way? Absolutely not. So analogous structures, same function, different composition or different makeup. Okay? And because of this, analogous structures cannot help us piece together the common ancestry line. Because, yeah, they might do the same thing, but they have no similarities other than they can both fly, or they can both swim, or they can both pick things up. So analogous structures do not help with common ancestry. Homologous, similar structure, different function, yes, common ancestry. Analogous, different structures, similar function, no common ancestry. The last type of structure to talk about would be vestigial structures. And this is basically a structure that used to have a purpose in one of your ancestors. Let's take the ostrich. They used to be able to fly way back in the day, but can ostriches fly now? Absolutely not. Our tailbone. We have a tailbone, but do we have tails? No, but it is thought that our early ancestors have a tail. Appendix, same situation. We have an appendix, but it does absolutely nothing. But scientists have thought that maybe our early ancestors needed the appendix maybe for some type of digestion purpose. So it's something that was useful at one point in time, but is no longer useful now. So would vestigial structures be a link to common ancestry? Yes, absolutely. Because it's like saying, yeah, my ancestor used that, and now we don't. And who knows, maybe in the future, a million years from now, humans won't be born with appendix because, well, we don't use it for anything. All right, let's look at kind of the recap, because really that's all section 4 is. So let's go back over this. When we look at fossils, we are just looking at basically pieces of the past. We're looking at the traces of an organism that no longer exists. And the big thing with fossils, I guess we can say, is link to common ancestry because if they have similarities to current species, that might have a link. Is that the only thing we can go off of? Oh, these fossils look the same? Absolutely not. That's why we have 3 other pieces of evidence to use for evolution. But yeah, link to common ancestry, basically similar structures. Okay, let's look at geography. Geography is just saying that you can find similar species oceans apart. Well, that doesn't make sense. Or think of the bird example. You have your main island, and all of a sudden, all around it, you have different birds, but that they closely resemble the mainland species. So maybe the beaks on this island are pointy because that's their food source. Maybe the beaks on this island are curved because that's their food source. Maybe the beaks on this island are gigantic because that's their food source. But they all resemble the same medium beak found on the mainland. Okay, well, food sources can do that. So geography would just kind of look at location. Embryology is when we look at the embryo. Early stages of development. If you see similarities amongst those early stages, like I said, there's our kind of our head and an eye, and they all kind of have this curvy thing with a gill slit, and that looks the same for all these different species. Even though later in life, we do not have gill slits, we do not have a tail. But that's saying early stages of development, we do show similarities with different species. Anatomy just looks at how you are built. And we have the homologous structures and vestigial structures. And notice right here, these are linked. And they're linked because both of these show common ancestry. This does not show common ancestors. So, no ancestry. And why is that? Well, homologous, think homo. Okay? Same structure. But what did we talk about? Is my hand the same thing as my dog's paw, which is the same thing as the flipper of a whale or a dolphin? No. They have different functions. All right, we'll go to analogous, the exact opposite. They have different structures, but same function. Think of the wing of an insect and the wing of a bat. They both help that creature fly, so they have the same function, but they're definitely not built the same. And the last one that shows common ancestry would be vestigial. And vestigial is just showing you it was once useful, but is no longer useful. So, useful in an ancestor. All right, I know 10.4 is kind of vocabulary rich and it's words that we don't use a lot. So if you have questions about 10.4, make sure you ask any one of your science teachers.